This project's quite complex. The project is fundamentally about whether biochar could be part of the apple industry's answer to achieving net zero. Apple orchards, by their very nature, are sequestering quite a lot of carbon. Of course, the activity in those orchards with tractors, that's also emitting carbon. But we do have a bit of a fundamental problem, and that is that whatever we're sequestering into those trees through the lifetime of the orchard, at the end of orchard life, the standard practice at the moment is to put trees into the middle of the orchard and burn them. So this project really was all about, could we fix that, and was biochar the solution to the emission of all that carbon at the end of orchard life?
We were having a conversation about the carbon footprint of growing apples, and somebody said to me, well, haven't we got a good news story to tell in that the apple trees are sequestering carbon during the course of their life? And of course they are, but orchards are really just a very long-term part of a very long-term rotation. And when you get to the end of an orchard's life, so current commercial practice is to remove the trees and set light to them, which unfortunately instantly return all of the carbon that's been sequestered during the previous 15 or 20 years, instantly returns it to the atmosphere. That was the very inception of the project.
Well, as growers, we farm increasingly in an increasing urban environment. So on the periphery of our farms, we've more often than not, we're now getting housing right up to the edge of the orchards, and it's becoming increasingly unacceptable for growers to keep putting matches to piles of trees. The smoke that's produced is quite considerable, and people are now aware of this sort of thing. And I think we have to look at ourselves as an industry and how others perceive us. And I think we have to look forward to how we can make that perception better of our industry. I think it reflects upon all of us. And if in the process of doing that we can also get a product that's going to help our establishment of trees, then this has got to be good for the whole business, and it has to make business sense, really.
The benefits of producing biochar in an orchard setting are that you can create a carbon credit, which allows your business to be more carbon neutral, get closer to being carbon zero. It also provides you with a range of products that you can use within your business, such as heat, which can either be used directly as heat or can be used in a CHP unit to generate electricity if you want to use it in any processing units. And there are other products that can come from the biochar process or the pyrolysis process, which can be any kind of extraction from the gases that are produced.
This project offers tremendous environmental benefits because it offers a carbon removal technology, or carbon dioxide removal technology, that is unique in its permanence and offers potentially another income stream for growers at the end of an orchard's life. And this was the very inception of the project, was that we would try and find a way of sequestering the carbon that the trees had captured during their lifetime and sequestering that for the long term. And it seemed neat to close the loop and investigate the use of biochar in an orchard situation, which has been unresearched up until now.
Biochar is produced from a pyrolysis reactor. It needs to come, it's supplied in as a feedstock. The feedstock can be made up of all sorts of biomass, but for this project we were obviously using the end-of-life orchard wood. It needs to be consistent. It needs to be consistent in size as well as in just being one product. So if you were to mix it with other types of wood, that wouldn't be very desirable in a pyrolysis unit. And then from there, depending on who you use, there's various forms of pyrolysis units and reactors that will give you your biochar?
We've done everything from end of life of the orchard, so when the trees are actually removed from the ground, we've then used wood from that to produce chip, so that we know we can process the trees into a form of material, biomass material that can be used in the biochar production system. And then we have reused that in establishment of new orchards. So we've been involved in the whole process really, apart from the actual production of the biochar itself.
From an on-farm viewpoint, and especially in fruit production and top fruit production, I think there's a very viable pathway to taking your end-of-life orchards, pyrolyzing them in a unit that can provide you with heat and the biochar, and then reusing that biochar on your ground for future plantings, and possibly to incorporate in existing orchards if the right equipment can be developed.
When we started this project, we had no idea what was out there on the market in terms of equipment to actually produce the biochar, in terms of kilns, etc. We started off with a UK company that was producing a very traditional kiln to produce biochar in, but quickly moved on from that to the machinery that we've seen in Europe, because Europe seems to be a step ahead of the UK in this. And we now know that there's no need to develop our own kiln system to make the biochar. We can actually buy off-the-shelf units.
My role in the project was twofold. It was to initially build a pyrolysis unit and pyrolyse biomass with a view to using that in the project. But upon a project change request, my role became looking at the various manufactured pyrolysis units that are out there and trying to do a comparison of those units, and also to do an economic assessment of the viability of producing biochar.
In order to really understand how globally researchers, academics and industry have been responding to the potential of biochar, we've done several international trips for this project, where we have travelled to Germany to see everything from individual farm scale pyrolysis units all the way up to industrial scale units. We've also travelled to California, which is one of the epicentres globally for biochar research and incorporation, where we attended the North American Biochar Conference, where we were able to speak to and listen to multiple academic experts in the sector, as well as see how biochar was incorporated into industry.
We've also, through the course of the project, had other parties approach the project team and say, you know, hey, if you're looking to put a unit in somewhere, we'd like to do that because we're a big greenhouse, glasshouse business, and we can use the heat. And we'd like, if you're going to put a unit in somewhere, we'd like to put it on our site so that we can have the benefit of the heat. So I think that's another opportunity that needs to be looked at. And I think these units, rather than being individual farm units, will probably be small area units. So product will be taken there, processed, and then the biochar will be brought back to farms.
One of our big changes within the project was to decide that we wanted to look at the life cycle analysis of the orchard throughout its lifetime. So when we started, we had put a piece of work into the project that was looking at the life cycle analysis of the biochar within an orcharding system. And I realised quite soon in that that was only a part of a very important jigsaw puzzle. So with Cranfield University, we then worked to look at the life cycle analysis of the orchard, from orchard establishment to the delivery of product into the supermarket, packed product into the supermarket. And that piece of work then puts into context the biochar life cycle analysis.
In the project, we set out to try and find out what the effect of adding biochar to the soil would be. And we did that in two ways. We've added biochar to planting holes of new trees when they're planted, and we're expecting to see rapid effects from that, if we're going to see anything. We've also applied biochar to the surface of the soil in established orchards, and we expect that to be much, much slower acting. So the question is about what effect it will have in orchards. We hope that in some situations it could improve the establishment of young trees by helping to overcome such things as apple replant disorder. The uncertainty we have here is that much of the biochar research that's been done has been done in augmenting or supplementing, improving poor or degraded soils. And in that situation, you see an uplift in the cation exchange capacity, so if you like, the nutrient holding capacity of the soil and the water holding capacity of the soil. And it's thought that biochar, which it has a very, very fine, microscopic porous structure, or a porous structure on a microscopic scale, and it's thought that these microsites provide habitats for soil organisms to live in. So it has essentially these three benefits. It improves the availability of nutrients through the biological, through uprating the soil biology. It improves the nutrient holding capacity of the soil, and it improves the water holding capacity of the soil.
The fruit growing, as you might imagine, is really, really good up until the point of end of orchard life, and then all the carbon that we've been capturing over the lifetime of the tree is subsequently released in current practice, because we literally put a match to trees and burn them at the end of their life. So what we wanted to do was try to harness that carbon, and the only way we could find that was time specific for harnessing the carbon from the trees was to turn it into biochar.
I think the first key finding is that biochar definitely has a beneficial effect on soil. But within perennial crops, within very fertile soils, the jury is out and we need to do more work. I think the second key finding is around the pyrolysis units. They're not all the same. Not all biochar is the same. And there are pyrolysis units that introduce no oxygen at all, where what you are producing, depending on the heat level, is quite a pure form of carbon. And then there are degrees of less pure. That's important if farmers want to earn carbon credits, and that market is developing at the moment. So I think there's work to be done on what that market will look like in the future for carbon credits, but also how pure do we need the biochar to be to get the value. And within that analysis, there's also a piece of work around the longevity of the biochar, the permanence of the biochar. Will it have a millennia permanence once it's put back into the soil? And if it does, it will make that much more valuable.
The Innovate UK funding definitely is important, and I don't think the project would have started or even been conceived if that wasn't a possibility.
British Apples and Pears has led the project, and we have a number of academic partners and businesses within the sector, and indeed some subcontractors of those businesses. Really important to get that boots on the ground experience to say what will work and what won't.
The number of collaborators that we have had who we've relied on, the amount of time that's been involved in the project, it's not something that any of us could have undertaken without the assistance of funding from Innovate UK.
Our role has really been to ensure that we are driving the innovation within this project, that we're ensuring this project will have high impact within the industry, and that the consortium is getting their highest value for money out of their investment within this project.
To bring as many academic partners together has been a challenge, but actually has meant that the learnings have been phenomenal, especially when we've got everybody in the room, either virtually, we've had some really long virtual meetings, or face-to-face.
I think it's very feasible that you could see in a year or two's time maybe small scale plants going onto farms where they can reuse their own product and use the byproducts that come from the process of making the biochar, so which is principally heat, within their own farm environment. So if for instance you had an on-farm pack house, you could reuse the heat from your biochar process to heat your pack house rather than having to buy in external energy to do that.
If there is government support behind this and people see that there is a viable economic strategy to it, the amount of units that are going to be available to growers will increase dramatically. I don't think it'll be long before there's a lot of manufacturers out there that have the capability to produce machines. And once that happens, I think the capital cost of the whole project, which can be prohibitive at the moment, but that will reduce, and I think that will be a big catalyst to this being something that everybody could be doing in as little as 5 years' time.
I believe what we've undertaken is the most detailed orchard life cycle analysis that's ever been carried out.